the next step is to find the longitude of the vertex. And we can't just automatically calculate what its longitude is, but we can calculate what its difference of longitude is, what its dLo v is, the difference away from the starting point to the vertex. So I've copied everything else over. I've also crossed out the dLo here because we no longer need the total difference of longitude between the starting and the ending point. It's not going to be relevant for any more formulas, but we should still keep it available. So once again, here's our starting point. Here's our CA right there as our angle away from the vertical. We know that that's our latitude of the vertex right there, so that the curve has to eventually hit that and then turn away. So now the question is, how far away will it be when it finally hits that point right there, when it hits that latitude that we've calculated and then starts to curve back down? And that will give us our dLo v. So we do sine of dLo v is equal to the cosine of, CA, the cosine of 60.72 divided by the sine of LV, which is down here, so 34.6. So we go into the equation. I want to test 1 second again that these are all saved. Okay. So cosine of t divided by the sine of A gets us that. We now do sine inverse. Wait, what? Oh, sorry. I didn't put in any value. Sine inverse of the answer, 59.3. So we can write dLo v is equal to 439. As usual, this is in degrees. We're not going to need to save this over here because this is only important for calculating the longitude of the vertex. And the way we're going to do that is we're going to convert it directly to degrees and minutes. So we take 59.4389, whatever, subtract 59 times 60, and we've got 59 degrees and 26.338 whatever minutes. So this right here is 59 degrees, 26.3 minutes. Now, it doesn't give a direction, and I've kind of given it away by drawing the illustration like this. We already know we're headed east. We know that we're going east and that to reach the vertex is to the east of us. So we know that this can be applied to the east. So let's take our starting longitude right here, which is, I guess I'll write here. Can you see that well? Yeah, okay. 070 degrees, 45 minutes west. And we're going to go 059 degrees, 26.3 minutes to the east. This doesn't mean find the difference of longitude between these two longitudes. It means go this many degrees and minutes east of our starting point. So now we're subtracting. So we do 45 minus 26, get 18.6, 18.66, so we'll round that to 7. And then we do 70 minus 59, we get 11, so 0.11 degrees. This is the longitude of the vertex. So now we can finally bring that over here. 0.11 degrees 18.7 minutes. We never fully passed into the Eastern Hemisphere. We're still in the West. So this is W. So to review, we started off by having our position, our starting position, having our course angle off of it of where we're pointing, and having the final latitude of our vertex found. Use that arc to find the difference in longitude between our point and the vertex. And then after converting that value to degrees and minutes, we were able to apply it to our starting point to find the the longitude of our vertex, which we can save over here, which is going to be extremely important because that's how we can now build our track.